Hey guys, and welcome to the new video in this neural networks and deep learning tutorial. In this video here, we're going to talk about point cloud classification. So we're going to use the PointNet in this video here, and then we're going to actually load in data as a point cloud. So we're going to load in a point cloud data set, and then we're going to train the neural network, and then we're going to do actual point cloud classification in this video here as well. But first of all, remember to join the Discord server. I'll link to that down in the description, where we talk about different kind of stuff within like convolutional neural networks, deep learning, artificial intelligence, and also computer vision in general. And also, if you have some problems with some of your projects, like you can go ask them in there, or if you just want inspiration for your own projects and stuff like that, come chat with us in there, and we can just like have this small conversation in our community here. So make sure to join that Discord server as well. So right now, into the first slide here, where we're going to talk about like the PointNet and the point cloud classification that we're going to do. So we're going to use this PointNet here, which is actually like the neural network that we're going to train on to actually like classify these point clouds here that we're going to load in. So to the left here on the image here, we can actually like see that we have this classification problem that we can get out from PointNet. So we're going to load in these different kind of like point clouds here that we're going to actually like do classification on, like see if this is a mog, if this is a table or a car, depending on like how the different kind of like features that we have in our point cloud are organized. And like point cloud is a really like unstructured data structure in that way, so we don't really know like how the different kind of data points is structured. So we need to like learn the different kind of features and see like if we can classify if this is a mock or table and car only from getting like a data structure with these point clouds here. But the PointNet is also able to like do part segmentation, so we can actually like segmentate parts out in PointNet. So we can see here on like, for example, the lamp, we can see like the top of the lamp here is one color and the lamp stamp is another color. So we can like actually like do segmentation of individual parts of objects with this PointNet here as well. But in this video here, we're actually like just going to concentrate and focus on doing this point cloud classification as we do over here to the left on the image. And with the PointNet, we can actually also do semantic segmentation. So now we're not only classifying the different kind of objects that we have in our semantic, and we are not only doing part segmentation, but we're actually like doing semantic segmentation. So we're combining all of these things here together, and then we have like a scene where we're segmenting out different kind of objects, giving them different kind of colors, but only getting in the point cloud of the semantic view that we're currently doing. So all these things here can be done with the PointNet here. And this video here, we're actually going to train our neural network, or like the PointNet here, to do classification on a data set, and then we're going to actually like see predictions on like what this PointNet here predicts when we just pass in a point cloud to it. So the architecture here of the PointNet neural network here is actually like a bit complicated and again really simple, because we only have like these different kind of features and layers that actually like just does the same and tries to find the different kind of features. So when we have a point cloud, it is, as I already said, it's an unstructured data structure. So we don't really know like in what order the different kind of like data points are in our point cloud. So we need to have like our convolutional neural network, or like our classification network, try to like do some different kind of things, right? So we can organize the different kind of like data points, so we don't have to like check for all combinations of our data points to try to do this classification problem. And then we also have some different kind of transformations, because we don't really know like how our point cloud is rotated and stuff like that when we just load it in. So we need to do some different kind of transformations, affine transformations, so we can actually like so we don't really care if our object is rotated and stuff like that when we pass it through our neural networks, and also when we're going to do new predictions on like rotations and like different kind of like ways that our point cloud is structured when we pass it to the neural network and do predictions on at the end. So first of all, here we have this classification network here, where we have these multi-layer perceptron things here, where we have these three-dimensional. So our point cloud is three-dimensional. So we have the x, y, and the z coordinate. And then when we pass it through these multi-layer perceptrons here, we actually like just expand the dimensions. So when we pass it through this layer here, for example, we expand the 3 dimensions here to 64, and then we just keep on doing the same thing here until we have like this global feature vector here, where we have the dimensions of 1024. Then we do max pooling, and then we'll have a vector here with all the global features that we can then pass to our segmentation network here to actually like just do the exact same thing again here, where we have these different kind of point features that we're going to extract from our information. And then at the end here, we get output scores here for both our input, like our classification network, and our segmentation network. So this is the overall architecture here that we actually have for the point cloud, or like for the PointNet here to do actually like point cloud segmentation. And then we also have these transforms here, which we pass, like we get the input here, and then we pass it through and first of all an input transform, and we later do it here again for the feature transform. And the thing here we do is just like affine transformation matrix, where we have this TNet here, where we get this, where we try to like estimate the affine transformation matrix if our point cloud is rotated around. And then we just get this 3x3 transformation matrix here that we just do matrix multiplication on our actual like point cloud data points that we load in. So we have one data point, and then we just multiply that by our affine transformation matrix, and then we actually like then we don't really care because we're like taking into account that our point cloud could be rotated. So these are some of the other different kind of PointNet applications that we can have. So I already showed you we can have like these partial input here, and then we can have the complete outputs over here to the right, where we can actually like do these part segmentating of the PointNet here. So we can actually like segmentate out different kind of features and different kind of objects inside of objects, and give them these different kind of colors here. And we can also like have a partial input, and then we can actually like pass it through the PointNet here and have a complete input, instead of we have this like noisy input point clouds over here to the left. And then to the right here, we can actually like have this semantic segmentating, where we have like this room here that we're going through, and then we get a point cloud from that room, and then we can actually like do this segmentating of the semantic, so we can like extract the different kind of like chairs and the table, the window, the whiteboard here, and the walls in the actual semantic view that we're doing, by only getting these point clouds in and doing this like part or like object segmentating in the semantic view. So we're not jumping into Google Colab here, and we're actually like going to show you like the code, how we can actually like load in our data and download our data set with the point clouds that we're going to like train our neural network on, and then do predictions on later on as well. And then we're going to show you like how we can create this PointNet network here that I showed you in the slides with the architecture. But first of all, we have this point cloud classification problem here with the PointNet. And first of all, we need to install this tramis here, so we can actually like load in the point cloud data, and then we can actually like show what is going on in point cloud data. And then we're going to use some other different kind of modules here that we already know from the deep learning tutorial here. So we're going to use NumPy and TensorFlow and then Keras to build our actual model. And then we're going to use Matplotlib to actually like plot the data points, or like our point cloud, so we can see what's going on and what is the neural network actually predicting. And then we just set a random seed here, so we can actually like just replicate our results again later on. So if I run this block of code here, we'll now load in the modules that we need here. And then because we're operating with images like a point clouds and stuff like that, so we're going to use a GPU to actually like make the training process faster with our neural network here, because we're using the GPU instead of the CPU. So we can use that here in Go Colab, as I already made a video about. And then if I run this block of code here, we can see that we actually like have one GPU available here in Google Colab now, that we can then use for training our neural network and then doing predictions later on as well. And then we're going to download the dataset here from the 3 division Princeton University here, where we're going to use this ModelNet 10 here. So we have 10 different kind of classes. We can also have the ModelNet 50 here, where we'll then have 50 classes instead of 10 classes. But for this example here, and just like so our neural network doesn't have to train for that long, we'll just use the ModelNet 10 here, where we have 10 different kind of classes, or like 10 different kind of classes where we have point clouds in. So if we run this block of code here, we will now like get the utils here from the file here that we load in from this website here. So we actually like download our data set, and then we just store like the directory to our data here in this data dir variable here, where we have this OS path join here, where we just get in this ModelNet 10 data set here. So if I run this block of code here, we will actually like download the data from this website here. And we can see that we have like 7 seconds left here until all of the data is downloaded from this website here. And then we can actually, like when we have downloaded our data set, we can go down and visualize a mesh from the data set. So to visualize the data set here, we're actually like going to use this try mesh here, and then we load in an example or a point cloud from the directory here that we have downloaded up here. So we have this chair, train, chair. So we take the first image here of the chair that we have downloaded. And then we have this path here that we can specify. So we can also like have like, for example, a chair, and we have a table, a monitor, and stuff like that. And then we have our training set, and then we have like the first sample here, or like the first image of our like data from this ModelNet 10 class here, or data set. So if we run this program here, we will actually like just visualize a mesh from the data set. So we can see that we load in this chair here from the data set, and we can like move it around here because we showed it with Matplotlib. So this is the chair that we're actually like going to create a point cloud on. So we can then sample point clouds on top of this chair here, so we actually like get a point cloud representation of this chair here that we can then do and pass to our neural network and do training on. So this is just one sample of our data set, and we can also like have different kind of like classes or objects here that we're going to train it on. So we have 10 in this case here, as already mentioned. And then when we have a mesh here, we can actually like sample the mesh here, so we get a point cloud of this chair here, and then we can just show the result as well. So actually like sample the mesh here that we loaded in, we just call this mesh.sample, and then we need to specify how many like points do we want to like sample this mesh here in our point cloud. So in this case here we have 2048 samples of this chair here, so we'll have 2048 data points of this chair here, which will correspond to the point cloud for the chair. And then we just use matplotlib here to actually like just made a scatter plot here of the points here that we sample our mesh on. So if I run this block of code here, we'll now sample our chair here, and we will plot the result here with the different kind of data points in our point cloud. And we can see that we now have a point cloud of this chair, or like this mesh that we loaded in up here. So now we have the point cloud here, and we'll do the exact same thing for all of the data, for the whole data set that we have. And then we can use these point clouds later on to actually like in the PointNet to train it on these point clouds here, and then do predictions on later on to actually like see if we can predict the objects by just getting these point clouds here. And then we can go down here, and then we have a function to actually like pass the data here. So each mesh is loaded, and then it's sampled into a point cloud, and it's returned as a numpy array. So here we're just doing the exact same thing as we just did up here with just one sample. So we're going to load in all of the different kind of objects that we have and all of the meshes that we have, and then we're going to load it in and sample it into a point cloud as we just did. So this is just like actually like parse our whole data set and sample our whole data set, so we get it into a point cloud, and then it is returned as a numpy array. So we can work with that later on, where it doesn't really like, it's an unstructured numpy array with all the data points that we have in our point cloud. So this is just a function here to do the actual same thing that we just did up above. And then we can parse the dataset here and process each of the classes, like each of the individual classes that we have in our training and the test set. So we go down here and specify the number of points that we want. So we want 2048 points, and we have 10 classes here. And then we have a batch size here, which we specify to 32. So we have 32 like images or like point clouds that we load in at each batch, and that when we're training our neural network. And then we can just get the training data points, or like the training point clouds here, and the test point clouds, and also the training labels and the test labels, and also the class map here, by just calling this parse dataset that we just specified up here, and then we specify the number of points, and then this parse dataset here will just return all of our training points, or like all of our training point clouds, and all of our test point clouds as well, with their corresponding labels. So we can then use that data to train our actual neural network. And then we're going to use this augmentation here for the data set here. So if you run this block of code up here, it will usually take up to 5 minutes to actually like do this sampling of our data set. So we also need to use augmentation for the training data set, because we have this unstructured data structure with a point cloud, or like all the data points in our point cloud doesn't really like, it's just unstructured, so it's not like in order every time. So we have like a number of different kind of like ways that our point cloud can be structured in. So we need to take that into account and try to reduce that. So we use augmentation for our training data set. So all of our classes have now been processed here. So we can see that it took around like 5 minutes to process all of the classes here, and actually like sample all different kind of classes and images here into a point cloud. So we can see that we have these 10 different kind of classes here that is now processed, and we now have in our training point and our test points here, we have to like have the point clouds that we can then use to train our neural network and do predictions on. So we have this sofa here, we have a nightstand, desk, chair, monitor, dresser, bed, toilet, table, and a bathtub. So these are the different 10 different kind of classes that we're going to train on and do predictions on. And then, as I just mentioned, we have this augmentation here for the training set here that I'm just going to run here now when we have our training set loaded in and processed. So now we'll do the augmentation here on the training test set here, and then we can actually like go down here and have the functions here to build our actual network here. So these are just like the different kind of layers that we have in our neural network here that I just specified, or like I showed you in the slides here, that we have this architecture. This is just like the architecture that we're going to use, and how we're actually like just changing the dimensions of the point cloud here and doing the transformations here to actually like to take into calculations that we're rotating our point cloud, and our point cloud is an unstructured data structure. So we have these convolutional layers here, and then we have the dense layers here. So we just like have one convolutional layer here, and then the 1D convolutional layer is followed up by a batch normalization layer. And because we're using point clouds here, which is just like points here in one dimension, so we use this convolutional one-dimensional layer here, which is followed up by a batch normalization layer. So if you don't really know like what these individual layers here are doing, go back in this deep learning tutorial here. I've talked about like all the different kind of things with convolutional neural networks and the layers in convolutional neural networks, and also what batch normalization is and what it does and how it's done. And then we use that for the convolutional layers as well. And we also do the same thing for the dense layers here. So when we have a dense layer, it is followed up by a batch normalization layer, and then both the convolutional and batch normalization layer here and the dense layer here is followed up by an activation layer where we use the ReLU activation function. So I'll just run this block of code here and go down to actually like have this function, so we can create the TNet layer. So these are the layers that we create down when we're doing the actual like rotation and the affine transformation to like take into account that we're rotating our point cloud around, and our point cloud is an unstructured data structure. So we have these bias here, and we have this regularizer here that we just load in from this class that we just created up above here. And then we just have these convolutional layers here where we just call this convolutional function here that we just specified up above. And then we just have these first convolutional layers here. We have a global max pooling layer here, and then after we have done a global max pooling, we actually like followed up with these dense layers here, so we can actually like do the classification and try to predict what class this point cloud is in. And then we just have the end here, we have the dense layer here, where we just like have the input layers here, which is the number of features times the number of features. We have the kernel initializer, the bias initializer to zeros because we want to use regularization. And then we have the activity regularizer here, where we just set equal to this regularizer that we created up here with the number of features that we have. So this is the TNet here that we're going to use to actually like do the classification here, or like the transformation of the point cloud here when we're going to pass data through our neural network. And then we just return here the layers here of the dot here. So we have the inputs here and the features T down here. So I'll just run this block of code here, which is the TNet that we specified and I showed you in the actual like architecture in the slides. And then down here we can actually like create the whole convolutional neural network that we're going to use to actually like train on, so we can do classification of our point cloud. So this is just exactly the same thing as the architecture that I showed you in the slides, where we have this TNet here with the input layers, and to actually like do the input transformation. And then we have two convolutional layers here where we have like these 32 filters or kernels here, so we can actually like do the feature extraction, or like we're upscaling the dimensions, or we're changing the dimensions in the first one here as I showed you in the architecture. And then we're following it up by transformation again. We are changing the dimensions again of our point in the point clouds. And then we use this global max pooling, which is followed up by these dense layers here, so we can actually like do the classification. And then the outputs here will just be equal to this dense layer here, where we have the number of classes. So in the case here of the last output layer here, we have 10 neurons in our output layer, so we can actually like classify which class we're in. And we're using the softmax activation function here, so we just get like a prediction of like how certain are we that we are in one of those classes, so we actually like get a probability of the different kind of classes that we're in. And then we have this model down here that we just specified. We have this model here with these input neurons and output neurons, and then we just call it this name here, the PointNet. And then we can create this summary here of the model after we've created it. So if I run this block code here, we'll actually like create the whole the whole neural network here that we're going to train on. And then we just have this a summary here that we can just get out, and it's really like, it's fairly complicated, but it's just like step by step what is in the architecture that I showed you in the slides. So we won't really go into details with these different kind of layers here, but it's just like these convolutional layers here followed up by batch normalization layer and an activation layer, and that just keeps repeating here. So we actually like we're just changing the dimension of our point cloud here, so we don't have this unstructured point cloud. And then at the end here we have this global max pooling, and then we're followed up by the dense layers as already specified, to actually like, so we can actually like get the classification problem at the end here. So if we just scroll down here to the bottom, we can see that we have the total parameters of 742,000 trainable parameters, and we have 6,000 non-trainable parameters here, which come from the regularization that we have created. So we have now created our convolutional neural network here that we're actually like going to train it on. So we train it on the data set that we already loaded in and processed. So then we're going to, first of all, we're going to compile it here. So we use the sparse categorical cross entropy loss function here because we just want to know like what class is it predicting and not like a probability of like this is 90% a chair and 10% of a table. We just want to have like the sparse categorical cross entropy. So we just want to know this is a chair or this is a table. So, and then we just specify the learning rate here as well, and we use the Atom optimizer, and then we just call this fit function here on the training data set that we have. We run it through 20 epochs, and we use the validation or like a test set here as the validation data while we're training the neural network here. So if I run this block of code here, we actually like compile it, and then we will train it, and then it will train for 20 epochs. So our neural network is now done training, and it took like around 10 to 12 minutes to actually like train it on all these 20 epochs here. So we can see that our loss here starts at 4.1 here, and our accuracy at 0.21 here. And then we can see that the loss and accuracies, and the loss is actually like decreasing here over the number of epochs, and our accuracy is actually like going fairly nice up. And we can see that we end at a loss of 1.76 here and an accuracy here of 0.77 or like close to 0.78 here. And we can see that the validation loss, we can't really take that into account because we're using these very unstructured data. But we can see here that the validation accuracy here is actually like going up. So we start with almost the same accuracy here as the training accuracy, and then we can see that it just keeps going up, the accuracy here epoch per epoch, and we can see that we end up an accuracy here of a 0.66 here. So we can see that it's not really that good as the training data here, but we could keep on training on neural network here until it gets better. But in this example here that I just wanted to show, we're just training it for 20 epochs in this example here as well. We could also like store, if we had like a better model here, like for example this was a better model than the previous ones, then we can actually just store that model, and then we could lay on load and dose weights to actually like do the predictions. But in this demonstration example here, we're just going to run it for 20 epochs, and then we're just going to go over the result here at the bottom, where we have this training accuracy here of almost 0.80. So now we're training neural network here on the training data. Then we can actually like go down here and do predictions and actually like visualize the predictions here that we can now like actually like do predictions on point cloud that the neural network hasn't trained on or like hasn't seen before. So we're going down here and we can just take the first here off the test data set. So we'll store the data here. So this will be a point cloud, and then we can actually like create this points here and the labels here for our test data. So we're going to take the test data here and store it in this variable data here. And then we're going to take the first batch here of our first batch or like the first couple of samples here from our data, and then we can store it in these points here and the labels here, and then we can actually just have these points and the labels here that we can now do predictions on. So actually like do predictions, we just use this model.predict here on the points here that we're going to do predictions on with the neural network that we have just trained. So that's why we're using this model.predict points here, and then we're going to store the predictions in this predictions variable here. And then down here we just use this argmax function here, so we actually just get the class of which the neural network has predicted, so we don't get like a probability of like how certain is it in this class. We just get the true label, so what class did it predict, and then we store the predictions in this predictions variable here. And then we can just create this like these points here, we just convert them to numpy array, so we now have the numpy array here in the points. So actually like plot it in NumPy like in matplotlib, so we actually like can plot the point clouds that we had now predicted on in matplotlib here, and then we print out the true labels, and then we print out the predicted labels as well, so we can see like how good is our neural network predicting on point cloud that it hasn't seen before. So if we run the block of code here, we will now do the actual predictions, and we'll also visualize the predictions. So if we go down here, we'll now get these point clouds here with their predictions and their corresponding labels. So the true labels, what the neural network should have predicted. So we can see here that the first here we're predicting that this is a chair, so this point cloud here is a chair, and the true label is also a chair. And here we can see another point cloud here where we have the prediction that this is a monitor, and this was correctly a monitor. But here we can see that we're now predicting that this is a chair, but it was actually like a monitor, and we can see that we don't really like predict like 100% because we only have this accuracy of almost like 70% accuracy with this neural network that we have now. Like we can keep on training the neural network and do some different kind of tweaks to it, and maybe use a bit more data augmentation to actually like get a better neural network, train it more to get like the accuracy higher, so we can actually like predict with more with more certainty, and also get a higher accuracy on our predictions. And then over here we can see that we're now predicting bathtub for this point cloud here, and the true label is actually like also a bathtub. And then down here we can see that we're predicting a dresser where it was originally a sofa, and we can see that we're predicting a nightstand here, and it's a nightstand. And this is actually like a fairly good sample of the chair here, and we can see that we're now predicting a chair because like this is a really good point cloud of this chair here that we're predicting on. And we can see that we actually like predict that this is the chair, which is correctly. And here we're predicting that this is a sofa, but it's actually like a bed. So we get some false positives here and there, but like if we have a really good point cloud, like for example up here with the chair, and also a bit here with bathtub, and with the chair here, like this is probably the best sample of the chair here. And then we can actually like predict with a really high accuracy what this point cloud is, or like what class or object this point cloud is. So this is a really good a nice neural network where we can actually like do point cloud. So we have an image, like a 3D image, or like a CAD model with these mesh files, and then you can actually like sample it into like these 3D points, which is points that we can actually like create a point cloud of. And then we have this point cloud here that we just pass to our neural network, trained on different kind of point clouds, and then we can actually like create new point clouds and do predictions on them. So we can actually like predict these different kind of classes here, or like what objects are, just by passing their point clouds to it. And then this can also be used for the part segmentating that we also went on over in the slides, and also this semantic segmentation. So when we're doing the semantic segmentation, it is just actually it's just doing this exact same thing here, but it's just doing on a semantic instead of just one sample of a point cloud that we're passing into a neural network. So this is a pretty nice neural network that we can do a lot of different kind of stuff on, and it's also like really nice that we can just have a point cloud that we sample from an image, and then we can just use this point cloud here to actually like predict what the objects are. So it doesn't know like in which order these different kind of points here comes into this data structure here, because we have this unstructured data structure, but we just have this point cloud here with unstructured data points, and then we can actually like do predictions and try to predict what class or what object this is by only giving it their point cloud. So this is a really nice neural network. So thank you guys for watching this video here, and remember to hit the subscribe button and bell notification under the video here, and also like this video here if you like the content and you want more of this in the future. I really appreciate the support, and just really help me and the YouTube channel out in a massive way. So I'm currently also doing a computer vision tutorial where we're talking about different kind of stuff within computer vision, and like camera calibration and stereo vision and stuff like that. And then later on we're going to focus on like how we can actually like use point cloud and how we can create point clouds with computer vision, and then we can actually like combine it with deep learning and computer vision with convolutional neural networks and also point clouds, and see how computer vision and deep learning like work together. So if you're interested in that tutorial, I'll link to it up here, or else I'll just see you next video, guys. Bye for now.